Hello everyone. So we have another problem where we have to graph a function. The graph of y equals f of x is shown on the right. Part A asks us to graph 2f of x, y equals f of x over 2, and y equals negative 2 f of x. How does each compare to the graph of y equals f of x? So it's probably handy to make a table for this problem. And we want a value for column for x, f of x, 2 times f of x over 2, and then the last one's going to be negative 2 f of x. So x, f of x, 2 f of x, f of x over 2, and negative 2 f of x. Alright, so let's remember some of the points we've been using. So over here we have negative 5, 7. Then we have over here it's about a half, so negative 1, 2.5, and comma 0. Over here we have negative 1, comma 4. We have over here 3, 0. And here we have 1, 2, 3, 4, 5, 2. Negative 2. Okay. So, well, we have negative 5 as an x value. And we know f of x gives us 7. 2 times f of x would give us 14, because we're multiplying the value of f of x. Then f of x over 2 would be 7 divided by 2, or 3.5. And then negative 2f of x would be negative 14. Okay, how about some of the other values? So we have negative 2.5, and f of x was equal to 0. And since we're just multiplying and dividing stuff, that would all end up being 0 as well. Interesting. Alright, so how about negative 1? Well, our f of x was a 4. 2 times 4 is 8. Half of 4 is 2. And negative 8 is f of x times negative 2. We have 3, 0, which again gives us just zeros. And then we have 5 and negative 2. Negative 2 times 2 is negative 4. Negative 2 divided by 2 is negative 1. And negative 2 times negative 2 is positive 4. Okay, so I'm going to graph 2f of x in blue. So we have 5 and negative 4. So 5 and negative 4. It's right there. We have 3 and 0, so that's just going to stay the same. Okay. We have negative 1 and 8. So negative 1 and 1, 2, 3, 4, 5, 6, 7, 8. Then we have this negative 2.5 and 0, so same thing. But then we have this point that's so negative 5, but positive 14. It's a very large value, so we're just going to have to roll with what we got. So here is our new function. It goes down, and then it goes way, well, very, very high up, eventually hitting that 14. Now that's interesting. but I can't really quite tell what's going on. Just, I mean, it looks to be definitely larger, and it seems to be kind of like getting skinnier in a way, like compressing on the x-axis, but definitely getting larger on that y-axis. So let's see, how about the next one? So I'm going to do f of x over 2 in red. So we have 5 and negative 1. So we got the 5 and then the negative 1. That would be here. 3 and 0, which we have. Negative 1 and 2. So negative 1, 2. Negative 2.5 and 0, we already got. And then negative 5 and 3.5. So 1, 2, 3.5. Okay. Let's connect all the pieces. So we're going to go from here to here. Then down here. And then up there. Interesting. Well, it's definitely smaller, a shrunken graph. Not nearly as big, certainly compared to the blue. Well, let's do the last one, which we'll do in purple. So negative 2 times f of x. So that's 5 and positive 4. So 5 and 1, 2, 3, 4 over here. Still have that 3, 0, negative 1, and negative 8. So negative 1, and then we have down 8 spots. Then negative 2.5 and 0, and then we have negative 5 and negative 14. Interesting. So a point like somewhere around there, we'll imagine. Now let's try to graph it. Now this is different, but definitely similar to what we had before. So got that, and something way down there. Okay, so what seems to be going on? How does each graph compare to the graph y equals f of x? Well, we notice that the purple graph is reflecting the values of the blue graph over the x-axis. That's interesting. We can see how it's mirrored, the blue and the purple. It's like a perfect mirror of each other. And we noted that blue compared to the original was a much larger graph. And we noted that the red graph is the smallest one of them all, which kind of makes sense because we're dividing, and when you think of division, you think of getting smaller. So let's see what part B says. Suppose f is a function. How is the graph of f of x related to the graph of y equals k times f of x, where k is some positive constant? What if it's greater than 1? Okay. If k is greater than 1, the graph enlarges its y values. And we know specifically, like, compared to the original function, like this is negative 1, 4 over here, it got twice as big because we're multiplying by 2, so by a factor of k, since we want to generalize. If k is between 0 and 1, that's like in the f divided by 2 example, the graph shrinks by a factor of k. I should say 1 over k. And if k is negative, then we reflected our values over the x-axis. And that's it.